Okay, so infinite series is, I guess, one of the next big topics of calculus that we want to study. I don't know, but to most people, and even me at the beginning, it was really difficult to understand what series were. I would say mostly because there weren't any good applications that I can see in the real world. But even though there isn't any applications that you can see at the level of math we're in, it's still really important to learn for future or higher level math. I think I read somewhere that once you start learning differential equations, you'll need infinite series a lot. And since differential equations is pretty much application of the world, you'll need infinite series to actually start talking about, I guess, differential equations. So that's why it's important to learn. So it's actually not really helpful at the level we are at mathematically, but in the future, if you go to higher level math, it'll actually be really important. So it's best to study the basics. Since we know a lot about sequences, we can build the definition of infinite series from that idea of sequences, right? Sequences, so let's say I have the sequence that's composed of infinite number of terms, right? So after the nth term, it still goes on forever. We have this. And how do I transition from a sequence to a series, or an infinite series, in fact? What we want to do is actually start this pattern of summing all the numbers, right? Because a series is basically just adding a bunch of numbers. So the way I like to think of infinite series is adding forever. So what we have here is s sub 1 equals a of 1. So this is called partial sum of whatever this number here is, the first term, for example, of first term, and then if we go into s sub 2, it would be a1 plus a2. We would say the partial sum of the first two terms, right? First two terms. And then if I go to s3, or s sub 3, it would be a1 plus a2 plus a3. This is the partial sum of the first three terms. And I guess logically, if we were to continue this all the way down to s sub n, this is a1 plus a2 plus a3 plus a4 plus a5 all the way to a sub n. And this is the partial sum of the first n terms. But we want to actually continue. We want to continue to infinity, or go on forever. And I guess it might be tricky to see here, or like understand it, but remember that a sum is just, it will have to be a number. It has to be a number, right? Whatever number, right? I don't know. It has to be some sort of number. Hopefully it will be some sort of number. So it's not just a bunch of terms that you're just going to string together. It's not like an expression. You have to just know that it's going to converge, or maybe not even converge to one number specifically, hopefully. And that's what we're going to actually be studying with infinite series, convergence and divergence. Not necessarily what's it going to go to. Like, is this series going to go to what number? You'll say like what, 4 or something. It's not really going to be like that. It's more of, does this converge or diverge? And how do you prove that it converges or diverges? And that's the main difficulty for infinite series. Is just that all these, there's going to be so many concepts, so many tests, that it can get confusing. So I think that's also another reason why a lot of people don't like infinite series, but we still have to learn it. So let's continue right here. I wanted to just show this, the partial sum of the first n terms, and we can actually write it in a better notation. And the notation looks confusing at first, but if you remember in the integrals, when you learned about how an integral came to be, it was just adding a bunch of rectangles, right? And the way we added a bunch of rectangles was with a capital letter called sigma. This is sigma. So what I'll say is that s sub n is equal to this. Basically what we do, if you want a quick review, is that this bottom right here is called an index, and I is the index. what we want to do is just start doing plug in I equals 1, so a sub 1, and then just increase I by 1, right? So 1, 2, 3, 4, 5, 6, 7. It will never be a fraction. At least I hope it doesn't. I just know it's whole numbers unless there's something out there that makes it not. But just for now, it's going to be 1, 2, 3, 4, 5, 6, 7 all the way. Keep going, increasing by 1. So that means it should be a2 plus a3, right? And then we're going to keep this going all the way until a sub n. This is good, but it's a finite series. Finite, meaning that you can count the number of terms. There are exactly n terms. We want to transition to infinite. And this is the definition that I'm gonna show you. Infinite series. Okay. We have this thing right here, the finite series. How do we transition from this finite to infinite? We can actually introduce something known as the limit as n approaches infinity of s sub n. So the number of terms is just going to start increasing to infinity. And the way we write it in the sigma notation, you can use any index. People like using n. I'm going to use n a lot. And we can actually put infinity, plop infinity on the top. So if we were to write the first couple terms, right, and then we speed ahead all the way to a sub n, but then we still go. Because it's infinite, right? We're not going to suddenly stop somewhere. It's just going to keep going forever. And this is the definition of an infinite series. It's basically we make the terms of the sequence, or the terms, we make the partial sum start adding every single term of the sequence. So you see how series and sequences are actually related. Series is just adding all the terms of a sequence. So then we transition to a sigma notation to make it more compact, right? This is what we'll probably see mostly, and then a sub n is kind of like just a function. For example, this is a function, but it could be any type of like sequence function if you want to think of it like that. So you'll mostly see it in this notation rather than the other two. And then, like with sequences, we want to actually study convergence and divergence, right? Converge slash diverge. So, I guess it comes in two parts. One's about convergence and one's about divergence. This is the convergence one. If it's equal to an L, a number, right? L, a number L, we say it converges. Otherwise, if it doesn't exist, or infinity, negative infinity, I'll just say infinity, negative infinity, or unknown, right? You can't specifically find the value or a value it can approach. It diverges. I guess the hardest part about divergence is the unknown part, because we can actually see easily that something like this will start diverging, right? You're going to add 1, then you're going to add 4, then 9, then 16, right? You're just going to keep adding. So we know that diverges. The unknown one's kind of tricky. Here's an example of an unknown one. Let's just start writing the first couple terms, right? So we just plug in n equals 1 here, so minus 1 to the 1, which is minus 1. And then you add minus 1 squared plus minus 1 cubed, right? This pattern will actually start to look like this. And notice that if we continue this off to infinity, we're not going to know which value it's going to be. Is it going to be something like this, 0, or is it going to be something like this, which is negative 1? So you have two choices, 0 or negative 1. It flip-flops. We don't know if it's going to be 0 or negative 1 on the infinitieth term, so we say it diverges. So there's an example of an unknown one. And we're basically going to be studying these two things. So we talked about the notation for series or infinite series. This is kind of like the main part of it. We're only going to be talking about kind of like this. So converge or diverge, that's pretty much the main bulk of this whole section of infinite series. We're going to be talking about a lot of tests, I'll say. Many that may sound, I guess, confusing at first, but there's a lot of good interpretations that I know and that I've read that's really helpful with learning about the convergence and divergence tests. So that's the idea of infinite series. It was just a lot of vocabulary to begin with. In the next many videos, we're going to be talking about how to determine if there's a convergence or a divergence of a series. And we're going to be looking at a lot of examples, so that's it for this video.